All right, this is the last lesson for Unit 5 of Geometry. We're going to be doing inequalities in two triangles. We're going to add one theorem. We're going to do a couple of pretty easy examples, and then we're going to be through. Hope you're liking this unit so far because we're almost to test time. Let's dive in. So the first theorem, this is a pretty easy theorem. This one has a lot of words and a lot of seconds and firsts and thirds and a lot of whatever else. But as far as conceptually, it's pretty straightforward. So let's read it and then we'll kind of explain what it means with this picture here. So if two sides of a triangle are congruent to two sides of another triangle, so like something like let me label this. This is something that didn't get really labeled in this picture, so let's label it with this. So like if this side is congruent to this side and then this side is congruent to that side. So if two sides are congruent to two sides of another triangle, so that's important in order for the hinge theorem to work, these two sides have to be congruent, have to have two same size pieces, right? Okay, so of another triangle and the included angle. Now that's a vocabulary word. We've had that before. The included angle. We're talking about the angle that's in between those two sides. So like this angle and this one right there, right? So the one that's in between, right? So the included angle is the one that's in between those two sides, right? So the included angle of the first triangle is larger, so that'd be this one, than the included angle of the second side. So if this angle is larger than that angle, which that's true over here, right? This one's larger. Then the third side of the first triangle, so this pink side, is longer than the third side of the second angle. This makes sense. This one really makes a lot of sense. I should have grabbed some like toothpicks or something because that would have been an easier way to kind of show you visually. Oh, look, there's a sticky note that's already folded in half. So if I have two sides, can you see that? Let me plop this up. So if I have two side lengths that are the exact same length, so like this guy and this guy, I wish this wasn't yellow, but here we are. Okay, so if this angle gets larger, this one right here, this side's got to be larger, and we get a smaller angle, then this side gets smaller. This makes sense. Now, if these two were different lengths, then it would be different and whatever else. So it's important that these two angles on the two triangles, so like this triangle and that triangle, or this triangle and this triangle, those sides have to be the same length. And then as the angle gets bigger, the third side gets bigger. That's what we're saying there in the hinge theorem, okay? So let's do a couple of examples using the hinge theorem. A lot of the problems on a homework set with this hinge theorem will be like, okay, which side is longer? And you'll just be like, okay, it's that one. So those problems would be really easy. These ones require a little bit more math. So we're going to do kind of two different styles of the same problem. So we're going to find the range of possible values of x. Now, so it's important to kind of identify where the two sides are that are the same. So like for this example, we've got these two that are marked the same, and then this one, of course, is the same because it's that's reflexive. It was just Thanksgiving break. My brain's still on break. Yeah, because of the reflexive property, this is congruent to that. So this is a hinge theorem problem because we've got sides here. So this one and this one are different, right? Now, which one is going to be bigger? Well, the bigger one is going to be this one, and we know that because 11 is greater than 9. You following so far? Hope so. So we want to find a range of possible values for x. So we know that this has to be greater than this one because 11 is greater than 9, right? Making sense so far? Easy peasy. So we can set up a really simple expression or a simple inequality to start with for 1/2 of the range of values, and that is that 6x plus 15 has got to be greater than 65. Right? Now we can solve that little baby inequality. That's going to be super simple to do. We subtract 15, that cancels, leaving us with 6x is greater than 50. And then we're going to divide by 6 on both sides. So x ends up equaling, what is 50 divided by 65? And do 50 divided by 6 equals 8.3333, which is the same, of course, as 8 1/3. So 8 1/3, right? So x has got to be greater than 8 1/3. Now, so that gives us 1/2 of it, but it could also be, we need to figure out, because it can't be infinite, right? We can't just, it can't be just greater than 8 1/3. Like, you couldn't put 4,286 in here and it still be a triangle. So where can it not get bigger then? Well, this can't, that any angle in a triangle cannot be greater than 180, right? It cannot be greater than 180 because there's 180 degrees in the whole triangle. So it's got to be this 6x plus 15, that angle has got to be, 15 has got to be less than 180, right? So it can get bigger and bigger and bigger and bigger. And then eventually we're in something else. We're in not a triangle anymore because we've broken this link or that link or whatever else, right? It gets too big. Like some of those theorems that we saw earlier in earlier lessons, right? So let's solve this guy for x. So let's subtract 15 from both sides. That one cancels, leaving us with 6x is less than 165. We're going to divide 6 on both sides. So x has got to be less than 165 divided by 6 is 2.5. 27.5. 27.5. So all we have to do now is to rewrite this mess into a compound inequality. So when we do a compound inequality, right, we put the smallest number on the left side. So 8 1/3. And then make sure, got all these notifications happening. Let me turn my volume off. Something has happened. All the things. There we go. Okay. 8 1/3. We got to make sure this matches. So we're changing to a less than symbol, see, because we're putting the number on the left side. We're flipping this all the way around, putting the x in the middle, and then right here, and then 27 1/2. Now, if you did this ranges right, easy way to check this, because some of you are like, well, what? We do it's always going to be both less than symbols. You just put the smallest number less than x less than largest number, always, because that's always how a range between this number and that number is going to look. It's always going to be the small number, 2 less than symbols, x in the middle, and then the bigger number, always, right? That's always how it's going to go. So let's do one more of these that's slightly different so we can get our nice well-roundedness. So we're going to, again, find the range of possible values for x. Now, this time we've got a little bit of a trickiness because we've got these triangles that have been twisted, right? So, like, for example, let's show you what I'm talking about for, oh, wrong layer, it's fine. Get to the right layer. For example, this, ooh, what's happening? There we go. This one goes with this one, right? Because 50 equals 50. What? No way, right? So, and these go with this one. So the included angle is the one in between those. So we're talking about this angle and that angle, which is good because that's the only ones that are given, right? So that's what we're talking about on this triangle. So this, which would go with the side across from it. Let me go a little bit smaller on my brush here. It would go with that side over there, and this one would go with that side over there. Now let me switch back to my regular brush. Okay, now, so that's how we're going. 68 goes with 47, 55 goes with that. So this time we're kind of going slightly at the opposite direction, but it's going to be the same concept as far as how we're going to write the formula and all that, right? So this 68, since this is 68 is bigger than 55, that means this has got to be bigger than that one, right? Okay, so that's what we're doing here. So we got to say that 5x plus 2 has got to be greater than, less than 47, right? Because this one's smaller, which means that one's small. This one's bigger, which means this one's bigger, right? Easy peasy, lemon squeezy. So 5x plus 2 has got to be this time. Oh, what have I done? It's got to be less than 47. Right? So that's different, right? And on this last one, it was going to be greater than the thing. So that's the key difference, which is going to lead to something different at the end of this problem. Other than that, we do it basically the same way. So we're going to solve for x. So we're going to subtract 2, cancel that, which gives us 5x is less than 45. And divide 5 on both sides. Divided by 5. Divided by 5. That cancels. So x has got to be less than 9. So what has it got to be greater than? Because we can't go, can't be infinitely small, right? This side can't end up being a negative side. We can't do, so it can only get smaller and smaller and smaller and smaller only so far. Well, how far can it go? Well, it can go down to 0. It's got to be bigger than 0, right? And so that's the other type of equation we're going to write. If we need to find what it's going to be bigger than, it's got to be bigger than 0, right? So for our other equation, it's going to be 5x plus 2 has got to be greater than 0. I'm going to solve that for x, so we're going to subtract 2 from both sides. That cancels, leaving us with 5x is greater than negative 2. I'm going to divide by 5 on both sides. So x has got to be greater than negative 2/5. Now, you notice I said it's got to be great. It can't be 0. It's got to be bigger than 0. X can be smaller. X can be negative, right? But this whole distance has to be greater than 0. And x can be different. Any real number, really, right? All right. Well, it can't be, but before we knew the range, it could be any real number in between our range. So we're going to write our inequality, compound inequality, the same way. We're going to put that smallest number, so negative 2/5. X has got to be greater than that, and it's got to be less than 9. And that's pretty much it. Like I say, the other type of problems will be like, which side is bigger? That one, because the angle's bigger. Which side is smaller? Or which angle is smaller? That one, because the side is smaller. Those are easy. We don't really need to see those. That's just basic hinge problem. Whatever else. This is where the rubber meets the road on these. We will see you in class if you're in my class. If you're not in my class, hopefully this was useful to you. Thanks, and have a great day. Bye-bye.